Hello students, and welcome to the final video of this calculus lesson. In this video, what we're going to cover is one final application of the second fundamental theorem of calculus. So let's get started. All right, so in this problem, we're going to be given a graph. And we want to say, okay, we know it's a continuous function defined from -4 to 3. We have a function g of x, and part of that function is an integral from 0 to x of f of t dt. So what I want to do is first find the value of g of 3. So let's kind of substitute in what I know. So g of 3 is going to be 1 over 2, 3 squared. Well, that should be pretty easy. Plus the integral from 0 to 3 f of t dt. All right, so again, I know that this is the graph of f above, and so I really will need to go from here, from 0 to 3, in order to figure out, all right, what is that area between the function and the x-axis. So first things first, I get 1/2 times 9, so 9/2. And then let's figure out what this area is. So I got the region above and the region below. And what I notice is a little bit hard to see, but what I notice is that they're exactly the same. So they're actually canceling each other out with what's above and what's below the x-axis. Okay, so I'm going to add 0 to this and I'm going to get 9/2. So let's see what happens when I want to find the value of g of -4. Well, I'm going to do the same thing. I'm going to start by substituting in the -4 that I know. So 1/2 -4 squared plus the integral from 0 to -4 f of t dt. This happened in the previous video that, all right, I don't want to go from 0 to -4 because that's backwards. So I'm going to flip my integral and I'm going to make this all negative. So this is equal to 1/2 times 16 minus the integral from -4 to 0 of f of t dt. So now let's look at my graph, and I'm going from -4 to 0. All right, and these are two quarter circles, so I'm going to end up going pi r squared divided by 4. So the first one has a radius of 1, and my second one has a radius of 3. So what I'm going to do is I'm going to come down here, I'm going to add up the two circles. So first, 16 divided by 2 is 8 minus, all right, and let's see, this first circle is below the x-axis, so I'm going to make sure that's negative. So negative pi r squared, so pi, and then it's 1 squared, so 1 squared. And then adding in the area above the x-axis, so from -3 to 0, which is going to be, so that's my radius. And I forgot to do something on this first one. I need, since it's a quarter circle, I need to divide this by 4. And then I need to add in the area above it, so that's going to be pi times 3 squared, so pi times 3 squared over 4. I'm not going to forget that 4 this time. All right, let's see what we get here. So I'm going to end up with 8 minus, so I get negative pi over 4 plus 9 pi over 4. I combine that, I get 8 pi over 4, which is 2 pi. So I get this equal to 8 minus 2 pi. Again, because everything has to be subtracted. So now let's look over here and let's find the value of g prime of 3. So let's see what we can do. So g prime of x is going to be, well, what is the derivative of 1/2 x squared? Bring the 2 down, subtract 1. So 2 times 1/2 is 1. So I just get x here. Plus, and since this is x in the integral from from 0 to x here, all I'm going to do is substitute that in. The derivative of x that I'm multiplying it by is times 1. So plus f of x and then times 1, the derivative of x. Okay, so I want to find, all right, what is g prime of 3? Well, that's going to be 3 plus f of 3. So let's go grab f of 3 from the graph. So f of 3 up here is going to be -3. So I get this equal to 3 plus -3, or 3 minus 3, which is 0. So g prime of 3 equals 0. And we're going to do a similar thing here to the second derivative of g of 2. So I want to figure out, all right, what is g double prime of x? Well, I already have g prime of x over here, so let's see. I'm going to get 1 plus f prime of x. All right, let's see what happens now. G double prime of 2, I'm gonna get 1 plus f prime of 2. Let's hope there's a derivative that we can get. So f prime of 2, I want the slope at 2. So that's 2. All right, it is on this line, and I can figure out what the slope is. So I'm going down 3 and over 1.5. So 1 plus down 3 and over 1.5. All right. Negative 3 divided by 1.5, that's minus 2. So I'm going to get 1 minus 2. So G prime of, G double prime at 2 is going to be negative 1, which means that G of x, or G at negative 1, what's the behavior? Well, we know it's concave down. G prime at 3, well, we know that there is a critical point that we can work with. So again, making connections to some of the things that you've already learned about in terms of maximums and minimums, concavity, points of inflection, things like that. So again, a quick video going over one final example of using the second fundamental theorem of calculus. Of course, if you need help on any of these problems, feel free to always reach out to me. I am Mr. Hernandez, and this is Mr. Hernandez Teaches.